Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface in Eclipse IDE, and I'm going to discuss a very important topic on how to include the dynamic libraries into our jar files when we export a project as a jar file. All right. So in the past lectures, we discussed the basic steps that we need to take to use JNI in Eclipse IDE. We said that we need the C++ development plugin for Eclipse IDE. We need to declare the methods that we want to bridge with JNI and call their corresponding C++ methods using the native keyword. And then we had to, step 3 was very important step, which was configuring the external tools for Java Edge to be able to generate the header file. And we said that we have to point it to the bin directory, the directory that contains all the class files, .class files, not .java file, because Java Edge, the tool that generates the header files, it acts on the basically class files. And then we said that we generate the header files, and then we create the C++ project, create the source folder, include those header files into our .cpp, and then set the target artifact for the C++ project into set it to dynamic libraries. We have to make sure that we include the JDK include folders which contain the JNI and JNI_MD, which is the machine dependent, into the compiler path of our C project. And then after creating the dynamic library, we add it to our Java project and set the -d java.library.path to the absolute path that points to the dynamic library folder. Okay, and then we said that we use static initializers to load the dynamic library. And the reason we use static initializers was because we want to load the library into memory, first of all, only once. We don't want to load it each time an instance of the class is being created. So we want to only load it once, and static initializers are always run only once. Okay, and they are run the very first time a class is loaded into the memory by JVM. Okay, and the second, we want to make sure that basically the static we don't want to load it before trying to load a class into memory. So we want only the dynamic library to be loaded when it is being used, right? Before being used, we're not going to basically load it into memory. And we briefly discussed how to correctly set up the external tool in Eclipse IDE for the Java Edge. We said that we set the location to the bin folder of the JDK and then the Java Edge tool, and then the workspace must be pointed, the working directory must be pointed to the top folder of the class files, which in our case in Eclipse is the bin folder of the project. So the relative path is the workspace location - the project name - the bin folder. And then in the arguments we set the -JNI. And then I use one of the variables in Eclipse which puts the fully qualified name of the .class file. So $ curly brackets Java_type_name. This puts the fully qualified name of the class file. And the reason I use this variable because we might want to use basically the header files for multiple Java files in a project. So it's better to do this so we don't need to manually set the name here. Okay, so let's head to Eclipse. So far I created a Java project called Native, and it has 2 Java classes, test native and test2 native. Okay, and then and I create this C++ project test_native, and in the source folder we have these 2 header files, one header file for each class, and then the CPP project that includes the 2 header files and adds the body or implements the body for the all the basically native methods, right? We don't need to put all the implementation in one C++ file. We can have as many C++ files as we want, but here I just added the implementation of the both Java classes, Java files in one C++ project. So we have these two we have these two Java files, and there is only one C++ with two header files. So this CPP file includes both these header files, and then from there I implement the methods, all right, the C methods. And so the thing that I have added is I added this new native method that returns a string, and signature is speak. So it doesn't take any arguments, and it returns a Java string, right? And in the main method, I'm just calling the speak. So working with strings is very easy. Note that a string class in C++ is not a primitive type, right? So we have to be careful how we handle strings. So these are objects. So if I go to the header file for test native, you see that this method returns a JString, right? So JString is basically a pointer to a string object, JString object. Okay, so let me just open it. It's a pointer to the JString object. So what is this? This is a pointer again to J object. So all the Java non-primitive Java types get mapped to J object. But in order to make it easier for the user developer, they also added some specific objects that extend the J object. So for example, J string is basically extending the J object. So the type is J object. But for more readability, instead of always using J object, we're using J string, for example. Okay. And so going back here, so we need to return a J string. So how do we do that? If I go to the C++ file, you see I'm using this environment pointer. So this is a built-in that is provided by the JNI.h file, and I'm just calling this new string UTF and giving this string literal. So a string literal in C++ is a const char pointer. All right, so basically this function is just a utility function that converts a string literal from C++ to a Java string object. All right, so whenever we're dealing with objects and references, we use this environment variable, one of the functions or methods that it provides. So in the future lectures, I will look more in depth about this environment and different methods that are available in this pointer reference. Okay, so for now, what is important here, how do we create a jar file? Let's say I have this test native, it has a main method, and if I run this, so it does this calculation, multiply 1.1 by 2.2, which is a native method. So it runs in the C++. And then the speak method is also a native method, which is basically these two string literals from C++ come as a string object into Java, and then we just print them. All right, so this is very easy, and we're loading the library. Everything looks good. So let's try to basically export this as a jar. So I'm going to create a new folder. Let's call this the jar folder. And then this is a runnable jar. This is runnable class because it has a main. So I'm going to export as a runnable jar. So export, right click, export as a runnable jar. Next. So the run configuration is test native 1 is basically the configuration that I've been using. And note that in test native 1, I don't have any VM arguments. And again, to refresh your memory, that's because in Eclipse, we can do another way of setting the library.path. In the native source here, in the build path, I set up the native library location for the entire project, not for each run configuration, for the entire project, which is a much more convenient way. Okay, so native JNI. So this JNI folder has my dynamic library, and it's always set for all the Java classes in this project. So all I have to do, right click, export, runnable jar. Right, I choose the right configuration. I'm going to put it in the native project jar folder, and then let's set the name to test.jar, and I'm going to extract the required libraries into the generated jar. So finish. Now we have this jar folder which has our test.jar. So let's try to run it. So I'm going to go to show in System Explorer. So if I click on this jar folder and go to services, new terminal, add folder. So this is a jar file, so we can say java -jar and then click on this and drag it here to give it the absolute path, and we get the unsatisfied linked error, no test native in java.library.path. So obviously it cannot find this test native library in the java.library.path. So the first question is why. So we know that the jar file is basically a zipped folder, so I can unzip it from with a unzip software. So if you look at inside this, basically these are my source classes. This is the manifest, which just points to the main class. As you can see, it points to the main class correctly, but what we see is that the dynamic library is nowhere to be found in this jar file. So obviously if I create the jar file and give it to another person, they definitely cannot load the dynamic library because it's not inside this jar file. So how do we put this dynamic library into this jar file? We have to set it so that the compiler knows that it's a resource for the project. So instead of having a folder, we have to set this JNI folder that contains our dynamic library as a source folder. So I go right click on the folder, go to the build path, use as source folder. Now when we export as the jar, it also looks into this folder and copies this file into the jar file, because now this is a resource folder. So let's try it one more time. Right click, export, runnable jar, choose the right configuration, the run configuration, which is test native 1, that runs this class, the main inside this class, and it's for the native project, which is correct, and we're putting the Java jar artifact into the native jar folder. So everything looks good. The jar is created. So let's again look at this, unzip it. So now in this unzipped folder, we see that the dynamic library is in fact inside the jar file, which is very good news. Okay, so we have our classes, the manifest that points where the the main class is, main function is, and we have this dynamic library. So let's try to run this jar file again. So open terminal, clear java-jar, and then copy and drag and drop this to copy the absolute path. But what we see here is that it still throws this unsatisfied link error and says that I cannot find the I cannot find this test-native in the java.library.path. And the reason is that even though this dynamic library is inside this jar file, Java cannot load it because it has to be in a folder on the basically the operating system environment, somewhere on a folder, not inside the zip file. Jar file is just a zip file. So the Java JVM cannot still load it because it's inside the zip file, not inside the folder. So what we need to do, in fact, we need to somehow create a temporary folder somewhere in the operating system and then extract this dynamic library from this jar file, copy it into that temporary folder, and then from that folder load it into the Java memory. Okay, so that's what we need to do. So jar file is just a container for dynamic library, but Java cannot load the dynamic library from inside a zip folder. This dynamic library has to be inside some folder in the operating system. So the process might sound a little bit complicated, but luckily there is a Java file. I found this simple Java project on GitHub. So if you go to GitHub and search for native-utils, native-utils, you directly come to this Java project, and it's a very simple project. It has only one Java file, which is called NativeUtils, and you can download it and copy and paste it to your project. And what this NativeUtil does is exactly what I explained. So basically, instead of saying system.load library, you call this a static method Java load library from jar from this NativeUtils class. And what it does, it looks inside the jar file, finds the dynamic library then based on the name that you specify, and then creates a temporary folder, copies that dynamic library, extract it from the jar file, copies it into that temporary folder, and then it loads that dynamic library from that temporary folder into the memory. And then we can basically use that library loaded into the memory, be able to run our jar file with the correct library loaded into the memory. So I have already downloaded this Java file. It's called NativeUtils, and I created another folder here, util. It's a source folder, and it has my NativeUtils.java class. So it's only one Java class, and it doesn't have any external dependencies. It only depends on some of the classes from the JDK. So it's very easy to just copy and paste it into your project, wherever your project is. And now, instead of saying system.load library and the library name, what I'm going to do is to say NativeUtils.load library from jar, and we have to give it a path. And this path, we know that this dynamic library is copied in the top level in our jar file, right? It's not inside another folder. So we give it the root, and we say it's lib test native.dilib. Now, unlike the so it throws a IO exception, so we can catch it. For now, I'm just going to print the stack trace. What you see here is that I added the entire name. I didn't drop the lib and didn't drop the extension. So you have to add the entire name of the file. For the system.load library, you have to drop the lib and to drop the extension. But for this NativeUtils.load library from jar, you give it the relative path from inside the jar file. And we know that this library is going to be at the top level of the jar file. It's not going to be inside another folder. So we just say the entire name of the library here. So if I run this, even in the Java, it still works fine. So if I run this, it still works fine. Because again, this is, look at it as a more extended version of the system.load library. Okay. And now what we can do, we can just export and as a runnable jar, and then choose the right run configuration, which runs the main method in this class, test native, and then we're putting it in the native/jar folder, and finish. Now we have this jar file again. So let's look at the inside of this jar file. We expect to see the dynamic library at the top level of this jar file, because we said that this JNI folder that contains our dynamic library is a source folder, which means when we export the project, it also copies all the resources, basically all the files that are not Java files or class files, but are declared or put in the source folders. It also copies all of them in the jar file. So we have this dynamic library at the top level of the jar. So that's why we say that it's at top level. It's not inside another folder. Okay. So the good thing now is that, let me delete this. Now if I try to run this jar, it should work fine. So we say that java-jar and test.jar. Wow. See, now it works fine. So again, what happens behind the scene is that this NativeUtils class, this function, looks inside this jar class, which is basically a zip folder. So if we unzip it, we end up with this test folder, and it looks into the relative path that you give it from the top level of the jar file. Okay. So I told it, okay, the dynamic library is right at the top level. It's not inside another folder, which is correct. It's there. And then what it does then, it creates a temporary folder, which is each operating system by default has a temp folder, temporary folder, and it copies this file into that temporary folder of the operating system, and then it uses system.load instead of system.load library. So system.load basically requires an absolute path, and it already knows what the absolute path is to the extracted dynamic library. So it uses that, loads into the memory, and after the run finishes, it deletes the dynamic library from the temporary folder. And if we just go inside this load library from jar, we see that it obtains the file name from the path, and then check if the file name is okay, and prepare the temporary file. So it looks into, it creates a temporary direction, and the way it finds the path to the temporary folder of the operating system, it uses the system.get property java.io.temp directory. So this is one of the system properties that Java already knows based on the platform that we are on, Windows, Mac, Linux. So all operating systems have some temporary folder. And this code basically extracts the dynamic library, copies it into the temporary folder, and then whenever we load it, it loads it from that temporary folder. Okay? So I hope you enjoyed this lecture. I guess this is an important one, because most of the time when we use JNI, we want to also include that dynamic library into our jar file so that we can easily distribute it to other people. So I hope you enjoyed this, and I'll see you in the next one.